Alright, y'all, CB here, the NBS welder, and we are back at another Walmart. We're round back to the store, got a little doozins got to get done here on a loading dock. And what we see here is there's an area where a handle goes through the loading dock and it gets stuck in there from the top. When the handle gets pulled back by personnel standing up on the loading dock, that stands this loading dock up sort of like it is right now. Then when a truck pulls in, they let it back down and they're ready to go. Obviously the sleeve that the handle goes in has broke, and we're thinking of maybe doing a little upgrade on it and going with a little larger diameter. And they did find this handle that is a really nice handle with a stop on it, and I found a sleeve that fits it real well. So we're looking like that would be the right thing to do, to maybe upgrade the diameter and maybe do a little better job welding it on there than they did whenever this was originally done. So I'm using the 8-inch Milwaukee metal cutter. I cut me a piece of that 1.25-inch pipe. And the other thing we found out is we might want to extend the length of that handle a little bit to give a little better leverage. So I also have a piece of 3/4-inch pipe that fits inside of the handle that they bought, that I can slide into there and weld it in, which will extend the length of the handle a little bit, just for giving it a little bit more leverage. And I think there in the end, actually, we ended up cutting a little bit more off of this because it was so long it hit the concrete. But it's better to be too long and then trim it down till it works, because that way we know we've made it as long as we can. Because the longer it is, the more leverage it's going to give you to get that raised up so the truck can back under it. And then, of course, when the truck is backed under there and you let this loading ramp down, then they can drive their gizmos that haul the produce and the supplies and whatnot, in and out. And a lot of it will be on pallets and different whatnots. But anyway, obviously, if we're going to upgrade the diameter, we got to make a bigger hole. I got out the oxyacetylene torch. I got the oxygen on 40 psi. I got the acetylene on about 8 or 10. And I'm using an aught. It's either an aught or a double aught tip. It's not the smallest one, but it's a fairly small tip. And I didn't really find a way to make a good mark on that old rusty metal, so I just sort of whittled on it. The next thing I'm going to do is get out the Arc Captain MiG 145. I've got it set up with, it's already got a spool of wire in it, and it's a 30 thousandths Arc Captain flux core. Arc Captain flux core is definitely my favorite flux core wire. Generally in the 145, I like to leave the 030, and in the MiG 200, I leave the 035. Either one of those machines will run either diameter. It just seemed to me like it made sense to put the smaller wire in the smaller machine and the bigger wire in the bigger machine, although between the 030 and the 035 is not a huge difference, but there is a little bit of difference. So I've rolled a little bit of wire out, enough to get shoved in the gun, get it started into the gun. Then we connect the gun control wire, and then we hook up the ground, which the ground on flux core actually goes to the positive. So we've got, it's an electrode negative setup. I run the Arc Captain MiG 145 off the Miller Trailblazer 302, so I'm using my welding machine as a generator. And I have a special adapter I made where I run the Arc Captain MiG 145 off of the 220 outlet of the machine, but I'm only running it off 110 volt current. And that special adapter allows me to pull 110 off of the 220. And I do that because it never trips the circuit protection in the machine if I do that. I can run the MiG 145 on 145 as much as I want that way, and it won't trip circuit protection. So get my 1¼ pipe up there in position and go at it with the flux core. Get that welded on there. Some of the welding I did uphill, some of it I did downhill. And what I tend to do in a scenario like this, if there's a gap and I got to fill up a gap, I might run a little downhill first to get it filled in, and then maybe run uphill over that if there's not enough weld bead. If it's tight, I definitely would just go right into running uphill. And like I always say, for uphill or overhead or anything out of position, the flux core wire is really, really nice for that. The fact that it's electrode negative, it really helps to keep from having the drips and goobers that it's easy to get when you run overhead or run vertical. Another thing I noticed that they had not complained about, but this was something I saw. If you look where I'm grinding there, right in the area where we're working on the loading dock, they have these bumpers, and I saw these welds don't look like they're not looking too good. And then there's a little bracket down below that is broke, and it was this way on both sides. So maybe nice that I saw this so I could dab a little doodabbing on that before it fell plumb off. So I look around whenever I'm working on something. If I see something that I think gonna need a little doodabbing, I'll put it on there, while you're there. You always hear that, well, while you're there, just take care of that. But I did notice that this could be a potential issue from the where the bracket broke down below. And that weld there up above, it was just not a solid weld. Half of it was slag. Very porous, and of course with the rust and the slag that was in there, it was difficult to repair. And you can see on this one real easy, you can see what I did. I'm burning pretty hot, about 3 downhills on that upper section, and then I'll let it cool down, grind it a little bit, and then I run a couple of uphills, not real wide. But that second deal with the uphills kind of solidified it enough that I could go in with a real vertical weave and just cover everything up and solidify it. And on that bottom, I got it welded up. In the beginning part, I kind of had to jog the trigger, hit it and release it, but I got it. And then where we welded the sleeve into the ramp for the handle, here I'm welding around the top. So I just made one quick lap there around the top, and always impressed with how mighty this tiny little machine is. So we're just taking a look at what I welded here, and it's a little bit more gooder than what it was when we got here. And we tested a little bit on the handle on the ramp. I took, this is a part where I'm adding this piece of pipe, and the one thing I noticed about it is this thing, that ramp, I think it's heavier than it needs to be, especially that outer section. If they have too much more trouble with this, I would recommend replacing that end section with a plate that was a little bit thinner, because I think that this thing's built heavier than it needs to be.